Let's talk about serverless database processing with Cosmos DB and Azure Functions. A brief introduction about me. My name is Luis. I am from Mexico, although currently I am living in Czech Republic in the city of Zlin. I am pursuing my PhD at Tomas Bata University. I am also a professor, lecturer at this university and in Mexico. I am a Microsoft MVP in artificial intelligence and developer technologies. Here you have my email address. Feel free to reach out if you have any questions about the topic. I mostly focus on mobile applications with Xamarin. But yeah, sometimes we need to deal with data, or we need to have our information replicated in different regions, and that's what we are going to talk or discuss about. And well, you know, also community is important. So yeah, we have some user groups, mainly in Spanish, right? But okay, this is something really nice that we can gather with friends, at least virtually, and talk about common topics. So we are going to talk about Azure Cosmos DB, then Azure Functions, integration of these technologies. We are going to explore these functions in the portal, and finally some useful links. So let's start with Azure Cosmos DB, which is it is defined as a NoSQL database service for modern application development, globally accessible. So Azure Cosmos DB is this fully managed NoSQL database for modern application development. There we have some elements. NoSQL means that you are not bound to relational tables. You might have documents, you might have tables with specific information. Azure Cosmos DB is the globally distributed multi-model database service that provides, or that can be helpful to build planet-scale applications. Actually, it has been used by Microsoft for their internet-scale services for years, and now it is ready for us. It is globally distributed because when we create a resource, we can add Azure locations to our database anywhere across the world with just a few clicks, and Cosmos DB will replicate our content, to make it highly available. Most of the time, we want to reduce latency. So we want one way to do it is to keep the data closer to the users. If we have some system, some application that is being used in America, in Europe, in Asia, then instead of provisioning the resources in one region, we can have it distributed in different, and they count as replicas. Right? So every user will get the data from the closest data center or region. With that being said, Cosmos DB allows you to scale throughput and storage elastically and globally. You only pay for the storage and the throughput that you need. And this is also a quick or fast service, the response time is in millisecond terms. You can also add some auto scaling features, instant scalability, and fast speed. The business continuity is also assured with service level agreement that supports the availability and security. Application development is faster and more productive thanks to turnkey multi-region data distribution anywhere in the world. It also supports some open source APIs. We are going to talk about them later, but here you have the 5 ones: Table, Cassandra, SQL, Cosmos DB for Mongo, and Gremlin. And basically, Cosmos DB takes database administration off of your hands with automatic management. So actually, Cosmos DB is a fully managed service. You don't have to worry about updates, about patching. And it handles capacity management. So we mentioned the Elastically scale storage and throughput. This is useful for both small and large solutions. For example, you want to apply data logs, log stores, or perhaps you want to perform a notification broadcast to your thousands or even millions of users. Many customers, such as online retailers, need to scale throughput up and down during different times of the year. Retailers, for example, will have a lot of operations in these months, in these times, because of Christmas, shopping, and so on. So that means there will be a lot of read and write operations because of this shopping activity. On the other hand, perhaps the rest of the year, they don't need too much computational resources, so they can scale down to reduce the cost, to save cost, basically. This is a feature property already integrated in Azure Cosmos DB. Cosmos DB is one of the few databases that has a financially backed latency. With more than 99 SLA. This reliability is a great fit for applications with real-time requirements in matter of milliseconds, less than 9 milliseconds actually. This impacts customer satisfaction. We mentioned the turnkey global distribution. Your data can be anywhere, as close as the data, as the users need them. And this leverages the number of Azure regions that are currently, and of course, there are new Azure regions expected. For example, in America, there will be 2. One in Mexico in the coming years, and a new one in South America, in Chile, actually. This can also be useful for failover operations. If one of the regions has an issue, a network outage, for example, then we can fail over to another secondary region where we have our data, And this will reduce the downtime, right? While the other, let's say, our primary region is being repaired, all the requests will go to the secondary one or the other regions. So the application or the system will continue to be operative. Since we need to perform great operations in different, let's say, replicas, we need to consider a special term, consistency. But this is flexible. Cosmos DB does not force you to apply a strong consistency or an eventual one. It's up to you which one you need. The strong consistency means that the moment you update some data in your, let's say, in some of the replicas or some database, this information must also be replicated almost immediately to the other replicas, to the other regions. So anyone who reads that row, that data, will get the latest version, the most recent version. Eventual one, on the other side, it means I update some data, some row, then at some point, eventually, the other copies will get that value as well. Sometimes we don't want neither of these extremes. Sometimes we might have some bounded staleness. So that means that there are some updates in a specific row. Let's say I have, let's talk about a social network. So I make, I write a publication, a post. It goes viral, right? So let's say a lot of people react about it. And okay, at some point there are 1,376 likes. So this information is there in the database. It's updated. And I have a friend who lives in another continent, and they read that they see my post. They see the number of reactions, but for them, probably the value is 993. This is, let's say, some previous value, some value in before, right? That is behind the current one. It is still valid, let's say, in some context. Eventually, after some time, it will get that specific or exact value. So you can say that there is a lag between when an update occurs and when the other regions will get that value. They get some previous version of the data. And this depends on the scenario, because probably in a social network system, it is not really important at all to get the specific number of reactions. Also, because the volume of data or updates, operations that are generated makes it impossible for everyone to wait until all the updates are confirmed. Yes, we do need that the value to be precise at some time, and it will reach that stage. But we can be flexible in the replication of those values. So depending on the scenario, depending on how flexible you want to be, you can add different levels of consistency. And we mentioned you can use different APIs. Perhaps you know about SQL queries. So you can use that API, that Transact SQL, to query your information, your database. Probably you have some experience with key value pairs or with columns in NoSQL structures like MongoDB. You can still use that knowledge to continue working with Cosmos DB. When you create the resource, you are asked which API you want to use. In the end, this is a layer, right? On behind all the data is stored as documents. So this API is how you will access that information. It is also possible to have graphs that represent the different relations between objects. And for that, you will use Gremlin, for example. So customers can experience low latency, global distribution, core features of Azure Cosmos DB without needing to alter their data model or application code. And just to conclude this part and move to Azure Functions, here is some scenario. Where can we use Cosmos DB? So, for example, we can think about an IoT and big data scenario. We have some oil company, right, or wells. There are several, let's say, points across a country or even across the world. And each of these stations have a lot of IoT devices which send telemetry, which report the health of the equipment, stations, how much, I don't know, how much material is being collected, or just for monitoring purposes. Even production, right, when this product is transformed. We can bring together all this data that might be even generated per second. We can concentrate everything in an Azure IoT Hub, or it comes to Azure IoT Hub, we collect it, and we send it to, for example, Azure Stream Analytics. In turn, this data is pre-processed, let's say, a bit, and we send it to several destinations, such as data lake storage for further analysis, or even to Cosmos DB for further or immediate access. Perhaps we have a web applications or a mobile application that where we can see some dashboard what is the current status of all our stations. And these stations are located across the planet or across the country. Thousands of data are being generated per second. So we can see this information in almost real time. There is no downtime. Latency is reduced as much as possible. So this could be one case of a study for Cosmos DB application. Also, we might have some Power BI dashboard, for example, to get some for some analysis, or we can also create time series insights and perform some analysis to detect some anomaly, for example. And the second scenario is more about gaming. Of course, video game players want to get an interrupted user experience. It doesn't matter where the data is. They want to reduce lag. They want to play, have fun. So Cosmos DB can also be used to, for example, provide notifications through Azure Functions, and this is what we are going to. Well, this is another technology that we are going to cover. To inform users about some new implementation, for example. Now, a lot of data could be generated from the game itself. Mobile, website, right? A lot of telemetry data can also be collected. And we want to save it. Perhaps we are building some artificial intelligence or machine learning model for recommendations or for an effective marketing strategy. So we can use Cosmos DB as the storage solution for handling these thousands, millions of data that are being generated, especially if this game has a lot of success, right? Or even Cosmos DB can offer this value to make it available everywhere. Okay. Any question, any comment about Cosmos DB? Okay, nothing, that's fine. But so let's now talk about Azure Functions. Just a second. Yes. So Azure Functions is part of the evolution of application platforms. At the beginning, we started with on-premises. Everything was on-premise. So we have our server, we have storage, we have application running, connecting, we have network infrastructure. Usually, the developer of the application also has to consider a lot of things or questions, such as, okay, I have my server, but do I need a backup? What's the right size or capacity that the server and the backup server need? How can I deploy some update, some new code into the server? What services do I need to install? And even further, what operating system my server needs? Could it be an Ubuntu Linux distribution? It has to be Windows Server, which version, and so on. To overcome those high number of questions, virtualization came to the rescue. And not only about virtual machines, but also cloud virtual machines. So cloud providers like Azure, AWS, Google, and so brought or implemented this with the infrastructure as a service. So here, the responsibility, the questions for you are less. You don't have to worry on the hardware. You still need to consider the operating system, updates. Right? You don't have to worry about rack, or you need to acquire solid state disks or traditional hard drive disks. You can worry about less, but still, you cannot focus only on your application. Then platform as a service is the next evolution. So the cloud provider gives you a host, a virtual machine. The cloud provider will take care of the updates for you. And you just develop your application, deploy it there, and that's it. Platform as a service really simplifies the process. And you can scale as you need. And serverless would be the ultimate cloud native experience, because you simply focus on the code. Serverless doesn't mean that there is no server. We still need to run on infrastructure, but the serverless the infrastructure is further abstract, more than in platform as a service. So in your responsibility, you don't care about the server. You just focus on what gives value to your business, which is the code, which is your application. Other benefits are the event-driven experience, because you have your code in the cloud and you want to run it depending on some conditions. It is there, but what will enable your code? Perhaps it is an HTTP call. Perhaps it's some schedule, some time. I want to run this code every hour or exactly at 9 a.m. every day. So you can do that. Also, the cost is low, because actually this is called as micro billing. You are charged only for the time your code is running. That is, when it is triggered, how much time it executes or it runs. You are not billed by the fact of the code is stored or something. No, just by the executions, the execution time. You can even pay less than $1 for a moderate usage of Azure Functions, even less. Serverless can be integrated with DevOps, so you can deploy a service, an Azure function, for example, as part of your source code control as part of to develop microservices, especially. It can even be part of a Docker container. The microservices, serverless, DevOps are quite integrated as well. Because actually, you don't need the cloud to run a function. You can have it inside a container. You can take it anywhere you want. Even running on premises in your own server if you want. So you focus on the applications, not on the servers. Therefore, you will reach a faster time to market. The serverless offer in Azure includes Azure Functions and Logic Apps. Both allows us to create solutions, bring value to the company. Although depending on the user, sorry, not the user, but the person who is going to implement some solution is the resource that you are going to use. For citizen developers, for people who don't necessarily have development skills, they can go for Logic Apps. You are presented a designer, then you can add actions, you can connect elements, even external elements from Azure. Like, for example, you can send an email by using Outlook connector when a virtual machine is resized. Or you can, I don't know, connect it with GitHub Actions or with something, not necessarily from Microsoft. Even there is a Twilio platform which allows you to send WhatsApp messages. So you can even have that connector. The logic or the flow, you build flows, and there can be even conditions that will execute some part of the logic app or not. If you are a developer, you can use Azure Functions. You can write your code in C#, F#, even PowerShell is supported, Node.js, PHP. You can develop your application by using different IDEs, Visual Studio Code. As we said, you can even develop locally. When you are ready, you can deploy it to any target, the cloud, or your own server, even a Docker container. And you can always, as many Azure resources, monitor the health of this service. Azure Function is basically your code in the cloud, triggered by events, by the occurrence of some activity. Here we have the specifics. What can make your application to run? For example, a blob storage trigger. Let's say you develop an application, mobile application. The user takes a photo, and you have implemented a functionality that the user can save these photos into an online album. Let's say that we are using blob storage, or sorry, storage account, even the storage account SDK, to send this image and keep it in a container. So that's it. But we would like to automatically, when a new photo comes to some specific container in storage, we might want to run some code that creates copies of it, that produces escalated images. So this is possible. We can have this function that will take the new picture and produces the versions, the escalated versions. We will see the code that is needed in a few seconds, but usually it's not so much code. Other triggers include HTTP when we send a request, HTTP request, post, put, get, or even timer trigger. In this case, you want to execute some function at a specific time, or even frequency. Let's say some function that runs every 15 minutes. Besides the triggers, there are also the bindings. For example, in the case that we mentioned earlier, this new photo and also the container where that is being monitored can be part of the parameters for the function that we want to execute. So these bindings could be blob storage, input binding, or also an output, because we take the blob storage, the new one, and we produce copies. The copies are outputs of the function or are the results. And how can we use both triggers and bindings? Okay, so in there is a function.json file which contains that information. The trigger is an input binding. So for example, that means that in this container, there will be a new file. We can reference the file name. Let's say that's a parameter. We will know which blob arrived to our container. And please notice that this file name is also part of the function of the code, sorry. This file name could, okay, we can also have some other references, such as the content itself, like the array of bytes. And we also might have other bindings. As you can see, this is an out parameter, out binding. That means if we have some run or if we modify something, it will appear here. There we have the name of the parameter, output blob, and also the direction. And well, also the binding image, the same one. Oh, sorry. What about two things? First of all, the code. As you can see, there is no SDK usage here. There is no blob storage something, blob client, storage account, connect, use the connection string, and so. Well, that connection string is not exactly here, but this is a reference. In the serverless resource, or Azure Functions resource, we have application settings. The application settings are keys and values. So we will have a key with the name, for example, Azure Web Jobs Storage. And the value will be the connection string, yes, with the account, the access key, and whatever is needed. So in our bindings, the connection, let's say, property is the key in app settings or the setting in app settings that contains the actual value. Okay, then any question? Very quickly, let me just bring some jacket because it's very cold a bit. So, but if there is any question, in the meantime, feel free to raise your hand. So just 1 second. Struggling a bit. All right, so
it's getting chilly in Portugal.
Yeah. Okay, so yeah,
no questions.
Okay, good. Yes, it is. Previous days it was snowing, but still the temperature is low, around 2 or 1 degree, but the wind is makes it even cooler.
Yes, yes.
All right.
Okay, you can continue.
Thank you. So we have the integration. How can we? You saw earlier that Cosmos DB is an acceptable trigger, and it can also be a binding. With the native integration between Cosmos DB and Azure Functions, you can create database triggers, bindings in both directions, input and output, directly from your account. So this way you can create and deploy event-driven serverless applications with low latency access to enrich your data for a global user base. There are 3 ways to do it. The first one is the trigger. You can create an event-driven Azure Functions trigger for Cosmos DB. There is a change feed stream that monitors your container. If there is a change, if there is a new document, if there is some update, then the change feed stream reports that, activates or sends the trigger, pulls the trigger. If we have an Azure function configured for that, it is invoked. And then the code is executed. So this is one possible way. All the modified items, we can get them because we will get a collection of them. The second and third way would be to use the bindings. So we might have an Azure function, and this is the case that we are going to demonstrate, the other one as well. So we have the Azure function. We have some trigger, maybe HTTP trigger, timer trigger, that contains an input binding. So we have the app setting that has the connection string to Cosmos DB. Whenever we call whenever the trigger is pulled, we can read the data from our container, and you will see that the code is quite small or few. Then we can do whatever we need for it. So the Cosmos DB input binding is used for read operations, so we can filter, for example, as needed. And if you want to insert, delete, or update, code, documents, you can use the output binding for that. In this case, the output bindings write the data to the container when the function completes. And again, we might have a trigger activated by HTTP, by timer trigger, by some blob storage, whatever. And we can update the information there. Okay, so let's go for the demo. I have the code here, but it's better if I show the resources. So just let me find them. I have them in the other subscription. And I will also increase the size. So we have them here. All right. So, well, first of all, I have a Cosmos DB, which is this one, University. This is my resource. We have a container, students, database students DB. And, well, we can check the data that is there, right? I am using the SQL API. So I have my document, and we can get some items here, right? So here you can see there are around 7. Yes. In this case, right, we have some row key and also the partition key. We want to group data by some partition. It can be like faculty name, department name, city name. This can help us to, let's say, group similar data. And it will be easier to get all of them. In this case, there is no primary key at all, but we can identify unique data by the combination of both the ID and the ID or the row key, and the partition key. So that means there cannot be another ID9 and faculty chemistry. That combination cannot be, but I can have the same ID repeated, but in different faculty. That is okay. You can access the data here. And you see it's JSON content. There are some properties such as, special properties, let's say, that I need for this business: ID, faculty, name, semester. And the others are generated by Cosmos DB, such as the row ID, some self-reference, right? And the e-tag is used for the consistency, or also to know if some other operation modifies the data. For example, let's say we have a long-running process. And at the beginning, I obtain this document, number 10 from Faculty Informatics. And yeah, I get this value, the e-tag. So in the code, I perform some operations. And and when I am ready to update this row, I can take a look again to the e-tag. If it is the same from the one I obtained at the beginning, it means that no one else has modified this document. So probably, depending on the scenario, I can safely say, okay, update it, and that's it. But if the value is different, and by the way, sorry, and when you do that, when you update it, there will be a new e-tag. So that means that if you read some e-tag at the beginning, then do some processing, and in the meantime, probably some other client activity application modify that document. If you read it again, you will get different e-tag value. Thus, you might need to do something else, like, okay, roll back or something. It depends, right? Okay. So this is useful for the consistency and so. Okay, anyways. Yeah, we can also write the query, but yeah, we can also add new one. Yeah, so let's just run. And you can see all the data here, all the members, right? So we can apply this knowledge. Now that you have that you know about the storage, let's go to the functions. And in functions, I have this resource created. I can do it also in my computer, but I did it from the portal because we can also develop the functions from the portal. So, okay, I have functions, and I have some examples here. So let's start with the read operation, get students. So I have some code, but I will take a look at the integration. I mentioned you that there is a functions.json file, which, okay, if I go to code test, you will see it here. But it might not be easy to write all this JSON. What if there is some mistake? Or probably I don't know some of the syntax or properties. Well, in integration, you have a nice graphical user interface where you can actually modify the input or output bindings. The trigger, no, because when you create a function, you specify the trigger. If I click here on create, then besides the name of the function, I need to choose any of the triggers that I mentioned earlier, such as HTTP trigger, timer trigger, and others, right? Cosmos DB trigger, right? I can do it. And then the name, which is down there. Okay, just a second. Yeah, here, database name, collection. I can configure whatever is needed. So that's why it is not easy, or it is not allowed to change the trigger, but you can add or remove bindings as you need them. So let's wait while it is loading. Okay, here we are. So we have the inputs. And in the configuration, we have the binding type, some name. This name will be used in the code. So remember this one, input document. We set the name of our database, and you already discovered this information, the collection name. And here I select my connection. This value, as I said, well, I can create a new one, right? And it will help me to create this entry in the application settings. Because, for example, it will detect that is in this resource group, there is already an account connection, but probably I can add an entry on my own. If I I name the key, I have the value. Right? If I very quickly go to the settings, yeah, here on configuration, you will see this connection string. Let's just wait a bit. Okay, yeah, this is the one. University LV7 document DB. And the value is the connection string of the Cosmos DB account. Everything is there. So let's go back. Yes. So in the functions, you don't directly put the connection string, but a reference to it. So we have get students. So so in this case, we just configure the read operation, the input binding, sorry, input binding. And the output is just returned to HTTP. That's fine. Now let's go to the code. Well, the code is quite simple. I even have extra lines that I can remove because I already removed them. Okay, so I have a model for my data that I want to read. And please observe that, okay, this HTTP trigger will run on demand when I need it. And if you remember, I have input document parameter. This is a reference to the document collection. I can assume, or I can use it in this function as an enumerable of my model. And it will automatically perform the cast, conversion, parsing, whatever you want to name it. The other parameters are the context of the request, because we might have them. For example, in the update, we will have it. And some logger attached if we want to document something that is happening here. What's the code? Well, I just convert this into a list because maybe I want to perform some queries, some filter, whatever. And I just return it as part of an OK 200 status code and include that object there. There are two things I can do. I can either just get the function URL, copy it, and in the browser, I can paste it. And the data is there. So we have this JSON with the values. If you remember, for every document, there were a lot of properties, data. But in my model, I only consider, or for this purpose, only ID, faculty, name, and so on. And those are the only properties reported. If I include e-tag, it will be here as well. Yes. I can do whatever I want. I can sort it, filter, whatever. Right. Also here in Azure Functions, there is a workspace where I can test it. I can even add a body. This will be useful for the insert and update operations. Here I don't need anything. I can even remove this part. There is no query parameter. And that's it. I can just run it. And I will see the information here. We also have the console in case I send something to the logs. But yeah, you see the results there. The status 200, okay? And that's it. By default, well, this run, let's say, quickly. But if an Azure function has not been active for 10 minutes, I mean the resource for 10 minutes, it goes to pause mode or sleep mode, if you want to call it. That means, or that is what makes it possible to have short or reduced cost. But on the other hand, it might add latency because, for example, next time there is a new request and the resource is sleeping, probably that first call will fail because it takes time to wake up, but further requests will work. For example, I remember I had an application that uses the YouTube API. Users in a chat send some comment, and the comment is called by an Azure function. Sorry, no, it's the opposite. The comment is called by a WPF application, desktop application. This desktop in turn sends it to Azure Functions. But I remember that the first time that I was testing, okay, it was working, but sometimes users reported there is an issue. My first request doesn't work, but the next one, yes. And it's because of the time it takes to the server to wake up. What solution would be, and I did it, I created a timer trigger function that executes every 8-9 minutes, which ensures that the server is always running. And it doesn't impact the cost of the solution. I can show you later if you want the cost of that one. But as I said, I pay less than $1 for that. But okay. So 2 lines, well, also the model and no special library are needed. Systemnet is for the HTTP, that's it. Let's say all the work is done in the integration. Right? So yeah, direction input for the HTTP trigger and the input binding for the Cosmos DB. Insert operation, which is add student, is also an easy one. First, let's see the integration. Now we have output binding. You can see it here. Okay, no inputs, because we just want to call this function. We will pass in the body the new data. And there are 2 outputs, HTTP and Cosmos DB. The Cosmos DB configuration, you will know it. Okay, yeah, by the way, yeah, when you want to add some output, you configure it. Select the binding type, such as Cosmos DB, and then the rest of the information, right? Okay, but so in this one, we have the account connection setting and the rest. So in our function, we will have parameter, output document, database, the rest that you already know. And this one, okay, yeah, this is false because we already have this information. It says that if we want to create database and collection, and we specify the partition key to know if there is duplicate data. All right. After that, let's take a look at the code. And again, this one is simple. Okay, there is Newtons of JSON because I need to deserialize the content that comes from the request So here it is. First, we have the request. We have an out parameter, output document. This name aligns with what we have in the configuration. And that's it. Then I apply a stream reader to our body. This is the JSON payload. And we apply, for example, some deserialization to that object. With that, we simply create a new instance of the output document. Remember that Cosmos DB is not bound to a structure. So I can have whatever properties I might need here. Because I read data, I might stick to that structure, those properties. But basically, we have, okay, ID, data ID. So in the JSON, I will have this property, faculty, name, and semester, for example. And that's it. Actually, I don't even need this class in this case, because as I said, it is kind of free, and you will see. So I will save it. When you save it, this, let's say, code is compiled. It will check if there are any errors or warnings. We might get some warning, but that's fine. So let's just see. Sometimes I might need to, let's say, add space, save it again. Okay, yeah, so you see warning, but compilation succeeded. Now let's test it. For this one, of course, I cannot use the get, so I cannot also use directly the browser. So I will stick with the workspace. So here, of course, I will send post request. Of course, the URL is here. If I want to test it, let's say by Postman or in my applications. But okay, let's test it from here. We have post. The master key is not important. No query parameters, but then I have the body. And let's say I want to add this member. I think I have repeated, so let's say this one. From faculty, let's say Informatics, and the name. Let's say Carson from 6th semester. And let's run. After it is run, we will get the response in two places. First here, 200. Okay, I am not returning anything because I am just, by the way, just updating the document. That's it. I'm just returning OK result. Although I might return the whole object if I want it. But also in the console, you can see, okay, the function was executed and succeeded. There is no error. There is no anything that causes a mistake. I can come back to my get solution. And as you can see, in the end, I have my new data added there. Okay, with very few lines of code. And Azure Functions also recognizes that this is an output parameter. So let's say that the return is implicit for this one. Right? The return is for the HTTP function because we need to know if it was successful or not. Right? I might need to add some checks, some conditions, but okay, let's leave it simple. Let's keep it simple. And for update and delete, okay, let me show you the delete first, because this one is simpler. And the code that I use is exactly the same for update, except there is extra code. For update, the integration you know it's the same one as the insert. So we have output, and yeah, they're exactly the same. Our Cosmos DB. Although in the function JSON, I add two more things. Usually, when you want to modify some data, yes, you require the JSON payload that contains the data about the student. Let's say the latest or newest data for the student. Let's say I want to update the last name of that student. So that's okay. But how will it know what document, what specific row it is going to update? It is true that in the JSON body content, I can include the ID and the partition key. But what if those values are actually modified as well, even though that's not allowed? But let's say I want to take the values from some other place. For that, we can include in the route parameter of the trigger two, let's say, query parameters, ID and faculty. So that means that the URL will also need some ID, let's say 10, and the faculty. Of course, this will not work because this is not for get, it's just for the delete, but that's the idea. And okay, so I need to modify this in the JSON. I do this for the delete and also for the update. And by the way, in delete, I don't need the body, right? So yeah, that was just a mistake by me. But still, okay, so let's go to code. Let's go to the run CSX. And well, here I just perform some search, let's say. So there is feed options. We mentioned this one in the trigger. We create a collection URI object from students DB and students. And we create a query. This query is based on the collection URI, the option, and we pass the ID from the parameter. This ID is already part of the query parameters. It is already recognized. I don't have to. Yes, actually, it is here, right? I included it. String ID and faculty. It is part of the root, so it is part of this place. And then I can delete the document with that specific partition key. That is also another query parameter. Of course, if there is no ID, just return not found result, and that's it. So yeah, after we perform this operation in output document is again also an output parameter. Well, this one is a bit different, right? Sorry, it's not output parameter, but it has the connection string. So yeah, it requires a bit more code for update and delete. Even though, well, I recently received a comment that this might be simplified. I need to still check it. But OK. So after that, we perform the OK result, and that's it. So let's test it. Let's say I have here, I pass the ID and the faculty. Let's work with this one, 131. From faculty, oh, sorry. OK. And the faculty is physics. OK, it is there. Body doesn't matter at all. So let's run it. And the result will be 200, OK? If I refresh this, there is no 1031 object from physics. So it works. And finally, the update is exactly the same, except that it has a replacement because I use the body, correct? So let's go to the, OK, integration is exactly the same. You already know it. So in the code, we have, yeah, some references as well, some packages needed here. But OK, we process the payload that comes from the request body. So we deserialize it, similar to what we did in the insert, but OK, it's a different code, but whatever. Then the same code that you saw in the delete. But after that, we update the properties. So document set property name, and for example, whatever comes from the JSON payload. Set property value, semester, and so. As I said, someone told me that this code can be reduced by just updating the output document, but I have not checked it. I received this comment yesterday, so I need to check it. But then, as you can see, I have the replace document async. And that's it. Then let's test it. I will share some link where I have this code posted, so in case you need it. So let's say I want to update 917 from Informatics. Of course, I need this information to be consistent. OK. I for some reason it is not copying it, so sorry about that. Okay, now, yeah. So Informatics, oops, and let's say is Luis from 12. Okay, let's run it. Let's see the result. 200, OK, fine. And let's refresh this part. And now that object is not Carl anymore, it's Luis. Okay. If you want to check this, let's say in detail, I just shared in the chat the link step by step to create. I published this a few days ago, right? So you can get all the information there. And just to conclude, some other links which might be useful. In the documentation, there is a specific information about Cosmos DB and Azure Functions. Sorry, it's in Spanish, this part. But yeah, there is the integration. And there is also a nice video from a friend, Gabi, Azure Cosmos DB and Azure Functions integration. She explains the fifth actually that we mentioned earlier. So this might be also useful. I can pass the both links in the chat. In the meantime, please, if there is any question, feel free to post them. Just a second, because for some reason it has some format, so it is not nice how it appears. And I can also share again my contact details in case there is a question about it, or in case something was not clear or whatever. Just feel free to contact.